Alright, number 25. The length of a rectangle is 6 centimeters more than 3 times the width. The area of the rectangle is 45 centimeters squared. Find the length and the width of the rectangle. Write an equation to solve the problem. Alright, so I'm very visual. I like to draw a rectangle just to have a visual reference. The length is 6 more than 3 times the width. So if we said this is the width and this is the length, give them both an x, but then make an adjustment. They compared to the width. So the length is 3 times the width plus 6 more. So the length takes the width and said 3 times the width plus 6 more. So the length and the width, and then it said the area is 45 centimeters squared. Well, we know that length times width equals the area. So if we take over here and we say, okay, I've got this length and I multiply it by the width, which is x, it should equal 45. And so if we distribute this, we have 3x squared plus 6x equals 45. And we need to solve for this x so we can figure out what these amounts are. So solving these means we have to make sure it equals 0 to begin with for that part. So we're going to subtract the 45 from both sides. And now we're going to factor this. So I'm going to rewrite this over here. 3x squared plus 6x minus 45 equals 0. Alright, ignore the equal 0 part. This is the part we're going to factor. And the first step is to see if there's anything common to all 3 terms. And sure enough, you can pull out a 3. That's going to make our math a little bit easier. Okay, and that comes down, it's part of one of our factors. Alright, so if we factor this, we multiply the first and last, we get negative 15. List the factors of 15. The sign of the middle term tells you the sign of the largest factor in each set. But they had to multiply to make negative 15. So that meant the small ones had to be negative. Now we find what equals a positive 2, and right here it is. Now since this started with a 1x squared right here, we can go ahead and pop these answers in. We have now x here, and then one's minus 3. The other one is positive 5. So we factored this now to equal 0. Now we need to find out what the values of x are. So each factor we set equal to 0 and solve for x. Now we know we're only going to have 2 answers because our exponent was a 2 up here. That tells us we're going to have 2 answers. But we happen to have 3 factors. Well, watch what happens here. If we make this equal to 0, it gives us a false statement. 3 is never equal to 0. There's no x to solve for. How about this? We can solve this one. We'll add 3 to both sides. And here we can subtract 5 from both sides. Okay, so we have 3 and 5 are, 3 and negative 5 are our possible answers, but we have to choose one that works in our universe. We're going back over here to our rectangle. And we're saying that either x is a 3 or x is a negative 5. Now when you think about the length of a triangle, can you draw the side of something 3 centimeters? Yeah, I can do that if I have a ruler, no problem. Can I draw it a negative 5? Well, no. That doesn't work in our universe. You can't have a negative length on a line. So even though negative 5 works mathematically in the equation, 3 is the only answer for x. So this is going to be 3. And then our answer we also plug in for the other x. So if this side is 3, well then this is 3 times 3 plus 6. So 15 and 3 are the sides, the length and the width of this object.